Welcome back to the deep dive. Usually, we take a broad topic, something interesting from the news or science, and we just kind of explore it, for the sake of curiosity. We meander, we learn, we have a good time.
Yeah, but uh, today, today feels different. The energy is definitely different.
It really is. We aren't here for general curiosity today. We are here for a highly specific mission. We're going into battle mode.
We absolutely are.
Exactly. We are engaging in a targeted tactical preparation session because our listener, you specifically, the person with the headphones on right now, you have a massive day coming up this Friday.
Yeah, Friday's a day.
You are sitting for the Google Principal Architect FFI interview. That's the L7 role.
And look, let me just say upfront, congratulations.
Yeah.
Just getting into that room is a huge victory in itself. L7 is, well, it's not a standard engineering role.
Right.
In the hierarchy of Silicon Valley tech, this is the big leagues. This is what they call planetary scale territory.
The stakes are incredibly high. And we have gone through a mountain of source material for this. Internal leadership principles, system design white papers, the Google Cloud Architecture Framework, and we're going to distill all of it.
But we aren't going to do the 101 stuff today.
Definitely not. We aren't going to sit here and explain what a virtual machine is or, how a load balancer works.
God, I hope not. If you're interviewing for L7 and you need me to explain a VM, you might as well just turn this off and go back to bed.
Fair enough. We're assuming you are already an elite technologist. What we are focusing on today are the signals, the specific high-level signals that differentiate a staff engineer from a principal architect.
Right, we're talking about executive presence, the force multiplier effect, and the specific frameworks you absolutely need to crush the role-related knowledge in system design rounds.
The differentiation is key here.
It is. I've seen so many brilliant engineers fail this interview because they went in acting like a super senior engineer. They tried to code their way out of a strategy problem.
So let's start right there. The mindset shift. The source material uses this term, force multiplier, repeatedly.
It does.
It feels a little like corporate bingo, but in this context, it seems to mean something very specific. What is the fundamental difference between L6 and L7?
Think of it in terms of blast radius.
Blast radius.
Yeah. At L6, which is staff architect, you're usually the technical lead for a large product area.
Right.
Maybe you own search indexing or checkout. Your blast radius is that specific org.
Okay, so you're solving hard technical problems, but they are bounded. You know the edges of the map.
Exactly. You're the captain of a very large ship, but you're still just driving the ship.
Yeah.
At L7, those boundaries dissolve.
They just go away.
Completely. You are operating across the entire company and honestly, often across the entire industry. You aren't just solving a problem, you are defining what the problem actually is.
Wow, okay.
You are setting the technical vision that allows 500, maybe 1,000 other engineers to do their jobs effectively.
So if the L6 builds the bridge, the L7 decides where the bridge goes and why we are crossing the river in the first place.
Precisely. It's a complete shift from execution to orchestration. You are designing the environment where the execution happens. The sources actually call this designing the digital destiny of the enterprise.
That sounds heavy. Digital destiny.
It is heavy. I mean, at this level, you're dealing with multi-year transformations for Fortune 500 companies. If you get the architecture wrong, you don't just have a bug in production.
Right.
You have a stock price correction. You have a regulatory fine in the billions. That's the weight you need to carry into the room on Friday.
And to carry that weight, you need to speak the language. The research highlights this concept of dual fluency. So it seems to be the killer skill.
Oh, it's non-negotiable. You have to be bilingual.
Okay, what are the two languages?
Language one is executive. You need to speak C-suite. When you are talking to a CIO or a CFO, they do not care about Kubernetes pods.
They really don't.
No. They care about CapEx versus OpEx. They care about TCO, total cost of ownership. They care about risk mitigation.
Like, if we move to the cloud, will we get hacked? Will it cost more?
Exactly. How does this move increase our EBITDA? Or how does this accelerate our time to market so we can beat our main competitor? If you can't answer that, you aren't an L7.
And here is the trap, right? You also need to speak language too. Deep technical.
The engine room language.
Right.
You need to turn away from that CFO, look a site reliability engineer, an SRE dead in the eye, and debate database sharding strategies.
You have to talk P99, latency tail end, CAP theorem trade-offs, consistency models.
Yes. And you can't fake the second one because Google interviewers are those exact SREs.
They will smell fear.
They absolutely will. If you get stuck in the middle, like too technical for the boardroom, but too fluffy for the server room, You are in the uncanny valley of architecture.
The uncanny valley. I love that.
It's true, though. You will not get hired there. You need to be able to zoom in to the atomic level of the technology and then zoom all the way out to the 30,000-foot business view in the exact same sentence.
That is a terrifying tightrope to walk. But let's assume our listener has the technical chops. The other soft skill that kept popping up in the leadership principles was influence without authority.
Yeah, and this is probably the hardest part of the job.
Why is that?
Because at L7, you often do not have direct managerial authority over the teams executing your vision. You aren't their boss on the org chart.
You can't just order them to do things.
No, you can't just say use Spanner because I said so.
So how do you get 500 engineers to follow you into the fire if you can't actually fire them?
You use followership. You build consensus through data, through storytelling, and through what Google calls navigating ambiguity.
Navigating ambiguity. That's a phrase I see right here on the evaluation rubric. What does that actually look like in practice?
It's the defining characteristic. Look, junior engineers need a ticket with clear requirements. Senior engineers can take a vague requirement and clarify it. But principal architects,
What do?
they get dropped into a situation where map is blank, compass is broken, and the team is completely panicking.
And they are expected to say, follow me.
They're expected to say, here is the framework we will use to find the path. You create the guardrails. You don't micromanage the code. You architect the principles that keep the ship safe while everyone else rows.
You act as the stabilizer.
Exactly. When everyone else is freaking out about the unknown, the L7 is the one who says, I've seen this pattern before. Here is exactly how we break it down.
Okay, so that's the mindset. You are a force multiplier, you are bilingual, and you are a compass in the fog. Let's get tactical now. We really need to talk about the role-related knowledge interview, the RRK.
The RRK, yes.
This is often the first big hurdle on the on-site loop, isn't it?
It is. This is where they test if you can apply the Google toolkit to messy, real-world business problems. It is definitely not a trivia contest.
Right. They aren't going to ask you what is the maximum file size in cloud storage.
No, they're going to ask you to solve a business problem.
We found a framework in the prep materials that seems like absolute gold for this. The PCA thinking framework.
Ah, yeah.
It stands for Professional Cloud Architect, but the notes say this applies even more strictly at L7.
It absolutely does. If you take nothing else away from this whole deep dive, memorize this sequence. On Friday, they're going to give you a scenario.
Something like a global retailer wants to move their inventory system to the cloud to handle Black Friday traffic. Go.
Right. And your first instinct will be to panic.
Naturally.
Don't panic. And for the love of God, do not just blurt out, use Google Kubernetes Engine.
Why not? I mean, GKE is a great product.
It is. But because you haven't diagnosed the patient yet, you're prescribing surgery before you've even taken a pulse, you must use the framework. Step 1. Identify business goals.
Okay, break that down for us. How do you actually do that in the room?
You ask the interviewer directly. You say, before we talk tech, I need to understand the business drivers. Why are we doing this?
You pause the tech talk.
Exactly. Is the goal to increase revenue by capturing every single sale? Is the goal cost reduction because their on-prem data center lease is up and it's too expensive? Or is the goal compliance?
Right, because a system designed for the cheapest possible operation looks completely different from a system designed for the lowest possible latency.
Totally different. If the goal is cost, maybe we use preemptible VMs and batch processing. If the goal is speed and reliability, we use premium tier networking and global replication. You literally cannot architect until you know that North Star.
So you anchor the conversation in business value immediately.
Immediately. And that brings us to step 2, extract non-functional requirements. This is where you flex your architectural muscles. These are the agilities.
Reliability, scalability, availability, maintainability.
Yes, but you have to be specific. Don't just sit there and say high availability. Ask them, do we need 4 nines, 99.99%, or 5 nines, 99.999%?
Because the difference between those two numbers is millions of dollars in engineering effort.
Exactly. One allows for about 52 minutes of downtime a year. The other allows for 5 minutes.
Wow.
And ask about latency. Saying sub-second is way too vague for L7. Do you mean 500 milliseconds or 50 milliseconds? Ask about throughput. How many transactions per second? Doing this shows you have architectural intuition. You know the devil's in the details.
Then we move to step 3, recognize constraints.
The reality check.
What is stopping us?
Right. Does the client have a limited budget? Do they have a massive legacy mainframe that they simply refuse to turn off?
Or regulatory constraints. I imagine that's a huge one.
Yeah, it's massive.
Yeah.
Data residency. Think about it. If this retailer operates in Germany, the data cannot leave German soil due to GDPR. If you design a beautiful, globally distributed solution that replicates data to the US for backup, you have just broken the law. You failed the interview right there.
So the constraints essentially define the sandbox you are allowed to play in.
Yes. And only then, which brings us to step 4, do you along architecture patterns. Now you can finally say, okay, given we need 5 nines availability, and we have a data residency constraint in Germany, and we need to handle Black Friday spikes, I am proposing a microservices architecture on GKE, deployed across 3 zones in the Frankfurt region.
And finally, step 5. The source material highlights this as the absolute moneymaker.
It is. Justify trade-off.
Why is this the most important step?
Because there's no such thing as a perfect architecture. Every single decision has a cost.
Always a trade-off.
Always. If you pick Spanner, you get amazing consistency, but you pay for it in actual dollars and in write latency. If you pick NoSQL, you get incredible speed, but you lose that consistency. And L7 doesn't just pick the tech, they defend the pain of the choice.
So you have to say something like, I am choosing to pay more for Spanner because the business risk of selling the same item twice during Black Friday is unacceptable.
Boom. That is an L7 sentence right there. You have connected the technology choice directly to the business risk.
Yeah.
You aren't just a techie anymore. You are a risk manager.
I love that. So business goal, then non-functionals, constraints, architecture, trade-offs. It's basically a checklist for sanity.
Write it on the whiteboard. Literally.
Really?
Yes. It shows you are structured,
Yeah.
calms your nerves, and it immediately shows the interviewer you have a repeatable process.
Now, a lot of these scenarios often involve migration, and we saw this term, the migration factory. It sounds a bit, I don't know, industrial, doesn't it?
It's supposed to.
Yeah.
At L7, you aren't just moving one cute little app. You are moving an entire portfolio. You're moving 500 applications for a massive insurance company.
Right.
You cannot handcraft each one like some artisan. You need an assembly line.
So what are the stations on this assembly line?
First station is discovery and assessment. You can't migrate what you don't know exists. You need automated discovery tools to map all the dependencies.
Like App A talks to Database B, which talks to Mainframe C.
Exactly. If you move App A without moving Database B, you break the whole system.
Then you categorize them. This is where the 6 R's come in, right? Rehost, replatform, refactor, and so on.
You got it. You create blueprints. Type A app. It's a standard Tomcat server. We rehost, lift, and shift to compute engine. Or Type B app. It's a mess of microservices. We refactor to Cloud Run.
You industrialize the decision-making so the entire team can move fast.
That's the migration factory. And this connects directly to the Cloud Adoption Framework, the CAF.
Right, the CAF. The sources say this is your Bible for organizational change. It has 4 main pillars: learn, lead, scale, secure.
Yeah, and notice something there.
Lead and learn are soft skills.
They are, and this is a classic trap in the interview. If you design a perfect technical migration, but you don't account for the fact that the client's engineering team only knows Kubel, the project will fail.
So an L7 needs to step up and say, we need a training program.
You need to say, technically, we will use GKE, but organizationally, we need to establish a cloud center of excellence, a CCOE to upskill the staff. Otherwise, this amazing platform will just rot. You have to address people and process, not just technology.
The triad, people, process, technology.
Exactly. That distinction is huge. It moves you from just being a smart engineer to being a strategic partner.
The interviewer wants to know if you can actually land the plane, not just build it.
Precisely.
All right, let's pivot. We've done the strategy. Now we really need to get our hands dirty. Section 3, the technical deep dive. We need to talk about the Google Scale Stack, specifically data strategy.
Data is almost always the bottleneck at planetary scale.
Always.
Compute is easy. You just spin up more cores.
Definitely.
But state is hard. Storing data consistently across the world is literally a physics problem.
And Google has a very specific menu of options for this. The decision matrix usually comes down to relational versus non-relational and global versus regional. Let's start with the one everyone always talks about, Cloud Spanner.
Sanger. The crown jewel. The holy grail of Google databases.
Why is it the Holy Grail?
Because it breaks the traditional rules of computer science. Yeah, the CAP theorem, right?
Yeah, consistency, availability, partition tolerance. And the golden rule is you can only pick 2.
Right. For decades, we all believed you could only pick 2. Usually in a distributed system, you pick partition tolerance because networks will always break. And then you have to choose between availability, meaning it always works, or consistency, meaning the data is always correct everywhere.
And Spanner.
Spanner effectively says, I'll take all three, thank you very much. It is a globally distributed relational database with strong external consistency.
How is that even possible? Is it magic?
It's physics, it's hardware. They use atomic clocks and GPS receivers. They call it true time installed directly in the data centers to synchronize time globally.
Yeah.
This allows them to order transactions across the planet without waiting for a central coordinator to say yes.
That is wild. So when do I actually use it in an interview?
You use it when you need global consistency. Think about a global financial ledger or inventory management for a worldwide retailer.
Right. If you oversell a flight seat because your database was only eventually consistent, you have a very angry customer at the gate.
Exactly. Spanner prevents that entirely, and it gives you 99.999% availability. 5 nines.
Okay, but if it's so good, why don't we just use it for everything?
Cost. It is very expensive. And frankly, the write latency is higher than a local database because it has to replicate across geographic regions. It's fast, but it's not speed of light in a single room fast.
So if I need raw, unadulterated speed.
Then you use Cloud Bigtable.
Bigtable. The beast.
This is what powers Google Search, Gmail, Maps. It is a wide column NoSQL store. It is designed for massive, massive throughput.
The source notes mention some crazy numbers, like 10,000 writes per second per node.
And that's just a baseline. Spanner maxes out around, say, 3,500 to 22,500 writes per second per node, depending on the config. Bigtable is a fire hose. You can scale that throughput linearly. If you need a billion writes a second, you literally just add more nodes.
But, and here's the trade-off. It's eventually consistent for complex operations.
Yes, you don't get ACD transactions across multiple rows easily.
So what's the real-world use case?
Ad tech. If you are serving ads to a billion people, you need to record those impressions instantly. Or IoT time series data.
Like smart meters.
Right, if you have a million smart meters sending voltage readings every single second, you don't need transactional locking. You just need to ingest the fire hose without dropping data.
So Spanner for the bank, Bigtable for the fire hose.
That's the bumper sticker, yeah.
What about the basics? Cloud SQL.
Cloud SQL and AlloyDB. These are for lift and shift. If your client has a legacy Postgres or MySQL database, and they just want to move it to the cloud without rewriting the entire app, you use Cloud SQL.
It's a managed service.
A great managed service, but it is regional.
It doesn't span the planet like Spanner.
Not easily, no.
Right.
If you need to scale to millions of users globally, Cloud SQL will eventually hit a wall that Spanner just wouldn't. But for 90% of standard enterprise apps, it's perfect.
And finally, BigQuery. I feel like people misuse this one in interviews constantly.
Oh, all the time. BigQuery is an OLFP warehouse, online analytical processing. You do not run your application on BigQuery.
So you don't use it to look up a user's password when they log in?
Never. The latency is measured in seconds, not milliseconds. BigQuery is for asking questions like, how many blue widgets did we sell in Q3 across all territories?
Right.
It scans petabytes of data in seconds. It's for the business intelligence team, not the app server.
Got it. Transactional OLTP versus analytical OLP. Keep them separate. If you mix them up on the whiteboard, you fail the technical screen.
Without a doubt.
Now we have to talk about security. The days of perimeter security are over.
Completely over.
The whole castle and moat strategy where once you're inside the firewall, you're trusted.
That model is dead. Google killed it with BeyondCorp.
This is their implementation of zero trust.
Right. In an interview, if you start drawing traditional firewalls and VPNs as your primary defense, you look dated. You look like an L4 engineer from 2010.
Ouch. So what does an L7 draw instead?
You draw identity-based security. Access depends on who you are and the health of your device, not which network jack you happen to be plugged into.
What are the specific keywords the interviewer is listening for here?
Identity-aware proxy, or IAP. This basically replaces the VPN. It sits right in front of your app and checks credentials before the request even touches your server.
Okay, what else?
Context-aware access. It asks, is this user in a trusted country? Is their laptop encrypted? And you need to mention VPC service controls to prevent data exfiltration.
So if a hacker somehow steals my password, but they try to log in from an unmanaged device in a rogue country?
Access denied. BeyondCorp stops them cold. Weaving this into your system design shows you understand a modern, Google-wide security posture. It shows you think about security as an enabler, not just a gatekeeper.
Excellent. Okay, take a deep breath. We are arriving at section 4. the system design interview.
The gauntlet. This is where the rubber really meets the road.
This is where you stand at a whiteboard, whether it's virtual or physical, and they say something like, design Google Maps Street View.
And then they just go completely silent.
Silence, really?
Yes. The first rule of system design is, it is candidate-driven. They are actively testing your ability to drive the meeting. If you just stand there and ask, well, what do you want me to do? Yeah, you are failing.
You need to take the marker and lead.
You have to own the room.
So walk us through the choreography of this.
Phase 1, clarify requirements. Do not rush to draw boxes.
Yeah.
Ask questions. Is this global? Do we need real-time updates? Who are the actual users? What is the scale of the fleet?
You are basically building the spec with them.
Exactly. Phase 2, back of the envelope math. You have to demonstrate number sense.
Number sense.
Yeah. You need to be comfortable with powers of 10. You need to verify if the problem is even solvable with current hardware before you design it.
Let's do the Spotify example from the notes. It's a classic system design question. Design a music streaming service.
Okay, let's do it. Assume 100 million songs. The average song is roughly 5 megabytes.
Okay, so 100 million times 5. That's 500 million megabytes, which is 500 terabytes.
Good. But we need durability. Hard drives fail all the time, so we replicate everything, let's say, 3 times.
So that brings us to 1.5 petabytes of raw storage for the audio.
Exactly. Now, what about the metadata? The song titles, the artists, the album art pointers?
Well, that's just text. It's small. Maybe 100 bytes per song. So 100 million songs times 100 bytes. That's only 10 gigabytes.
See what just happened there.
We proved that the audio is a massive big data storage problem, perfect for object storage, but the metadata is tiny.
It fits in RAM. You could literally fit the entire index of Spotify's music catalog on a single high-end server's memory.
Wow, that changes the design completely.
Completely. Yeah. That is exactly why you do the math. It informs the architecture. If you tried to store the audio in a relational database, you'd go bankrupt. If you tried to store the metadata in a distributed file system, it'd be way too slow to search.
That makes so much sense. So let's look at the Google Maps Street View scenario. This is what you'd call a planetary scale ingestion problem.
Right. You have cars driving around the entire world, taking high-res photos constantly.
That is a massive write load.
Massive. And here is the L7 constraint they'll throw at you. The cars have terrible internet. They are driving through tunnels, rural areas. Connectivity is flaky at best.
So how do you handle the upload?
You need resumable uploads. You buffer the data on the car's local hard drive. When the car hits a strong 5G signal or Wi-Fi, it pushes data in chunks.
Where does it push to?
The images go to cloud storage GCS. It's cheap, incredibly durable object storage. The metadata like GPS coordinates, time, car ID goes to Bigtable.
Why a cable again?
Because of the right throughput. You have a high volume of sensor data coming in fast.
Right.
But here's the key architectural question. Do we process those images immediately?
Well, if we try to process them immediately and the image processing server happens to be down, the upload fails.
Right. That would be synchronous processing. It creates tight coupling, which is bad. We want asynchronous decoupling.
Decoupling. That's a magic word in these interviews.
You dump a message into PubSub. Hey, new image ID 12345 has arrived. The car doesn't care what happens next. It gets an OK from the queue and just keeps driving.
Then downstream, you have the image understanding team.
Right. They subscribe to that PubSub topic. A data flow pipeline wakes up, pulls the image, blurs the faces, reads the speed limit signs, and updates the map.
This sounds like a classic event-driven architecture.
It is. And it scales infinitely. If you suddenly add 10,000 more cars to the fleet, the PubSub queue just gets deeper. The system doesn't crash.
Let's talk about the CIP theorem in this specific context. Street View.
Okay. Partition tolerance is a given because, well, car networks fail. So do we choose consistency or availability?
Let's think. If the network is down, does the car stop recording?
No. The car must keep recording. We need high availability for ingestion.
Does it matter if the end user sees the new Street View photo instantly on Google Maps?
No. It can show up a week later and nobody cares. So we don't need immediate consistency. We choose AP availability and partition tolerance. And we accept eventual consistency.
And that is the L7 justification. I am choosing AP because ingestion availability is critical to the business, but read consistency is not.
Perfect. That shows you deeply understand the trade-off.
Are there any cheat codes for this section, patterns we should just default to?
There are 3 of them you should memorize. Number 1, managed over self-managed.
Meaning?
Never say, I will install Redis on a VM. Say, I will use memory store. Google wants to see you reducing toil. They want to see you using the platform, not fighting it.
Makes sense. Number 2.
Global versus regional. Always check if you need a global load balancer using an Anycast IP. It's Google's superpower. It terminates the user's connection at the nearest point of presence anywhere in the world and then rides Google's private fiber backbone the rest of the way.
Lowering latency massively. And number 3.
Real-time versus batch. Don't build a Ferrari just to deliver the mail.
I like that.
If the business only needs a report once a day, suggest a batch job. It's cheaper and simpler. It shows you have economic thinking.
We've covered the tech, the strategy, the frameworks, but there is one final hurdle. Section 5. Leadership and Googliness.
The culture check. And please don't roll your eyes at this. This is where many highly qualified candidates fail.
It's not just about being nice, is it?
No, it's about intellectual humility and psychological safety.
What does intellectual humility actually look like in an interview setting?
It looks like this. You're at the whiteboard, and the interviewer points out a flaw in your design. They say, hey, if you use a single pub sub Q there, won't that create a hotspot?
And your natural instinct is to defend your design. No,
Because fight that instinct. The correct L7 answer is, that is a great catch. You were absolutely right. Under high load, that would be a bottleneck. To fix that, I had shard the topic by region.
You pivot and solve it together.
Yes, they want to know, are you coachable? Are you collaborative? Or are you a brilliant jerk? Google does not hire brilliant jerks. They want someone who values the right answer over being right.
And what about bias for action?
This goes right back to ambiguity. You might get asked a behavioral question like, the team is gridlocked, half want to use React, half want to use Angular. What do you do?
Do you flip a coin? Do you just pound the table and decide?
No. You say, I would facilitate a data-driven experiment. We will spend 1 week prototyping the critical path in both frameworks. We will measure performance and developer velocity. Then we will let the data decide.
You move the decision from opinion to fact.
Exactly.
Yeah.
You unblock the team. You aren't a dictator. You are a catalyst.
There's that phrase again, influence without authority.
We keep coming back to it because it literally is the job.
We have covered a massive amount of ground today. We're pushing time. Let's bring this home for our listener. You are walking into the building or, clicking the meet link on Friday. Give them the summary battle plan.
Okay. Here is the final checklist. 1. Mindset. You are not a senior engineer interviewing for a job. You are a peer. You are a force multiplier. Act like it.
2.
The framework. Use the PCA thinking framework. Business goal, constraints, architecture, trade-offs. It anchors you when you panic.
3.
The tech. Know the data strategy cold. Spanner for global consistency. Bigtable for massive throughput. Beyond Corp for security.
4.
The design. Drive the conversation. Do the math out loud. Always justify the why.
And 5.
The culture. Be humble. Be a mentor. Show how you grow the team, not just the code base.
And remember, they aren't looking for a walking encyclopedia.
No, they are hiring you for your judgment. They want to see how you think when you don't know the answer. They want to see you reason your way through the fog.
One final thought, a curveball to leave you with.
Yeah, we talked a lot about Google Scale and Cloud Native, but here is the ultimate L7 flex. Know when not to use the cloud.
Really? In a Google Cloud interview?
Yes. If you can look the interviewer in the eye and say, actually, for this specific component, maybe it's high-frequency trading where every single microsecond counts, or a legacy system with extreme data sovereignty constraints, we should actually keep this on-premise. That shows incredible maturity.
It shows you care about the customer's actual outcome more than you care about the Google sales quota.
Exactly. It shows you are a trusted advisor. And that is what a principal architect is.
That is a total power move. Use it wisely.
Good luck on Friday. You have done the prep. You have the frameworks. Now go crush it.
You've got this. We'll see you next time on The Deep Dive.